In the world of software development, design patterns are like tried and true blueprints. They offer reusable solutions to common problems. Recognizing these patterns is crucial for building robust and maintainable software. This essay focuses on identifying 4 key patterns: Observer, Facade, Decorator, and Flyweight. We'll delve into their unique characteristics. We will explore practical examples to understand their application. This exploration will equip you with the knowledge to identify and utilize these patterns effectively. The observer pattern establishes a one-to-many dependency. One object, the subject, maintains a list of its dependents called observers. When the subject's state changes, it automatically notifies all its observers. This pattern promotes loose coupling. The subject doesn't need to know the concrete classes of its observers. Key clues to identify the observer pattern include a one-to-many relationship between objects, automatic notification of state changes, and loose coupling between the subject and its observers. Imagine a bustling news agency. It publishes a variety of news articles daily, covering everything from politics to entertainment. Subscribers, eager to stay informed, want to receive updates whenever a new article is published. They rely on timely notifications to keep up with the latest news. This scenario perfectly illustrates the observer pattern in action. The observer pattern is a software design pattern in which an object known as the subject maintains a list of its dependents called observers and notifies them of any state changes, usually by calling one of their methods. In this case, the news agency acts as the subject. The subscribers, who are eager readers, are the observers. They are always ready to receive the latest updates. When a new article is published, the agency automatically notifies all its subscribers. This ensures that everyone stays informed without having to constantly check the website for updates. Another example of the observer pattern can be found in UI frameworks. In software development, maintaining a responsive and dynamic user interface is crucial. Changes in a data model, which acts as the subject, trigger updates in UI elements, the observers. This automatic update mechanism ensures that the user interface reflects the most current data without manual intervention. This ensures that the UI stays consistent with the underlying data. Whether it's a news agency keeping its readers informed or a software application maintaining a dynamic interface, the observer pattern plays a crucial role in ensuring seamless updates and consistency. The facade pattern provides a simplified interface to a complex subsystem. It hides the intricacies of the subsystem behind a single, easy-to-use interface. This pattern reduces the learning curve for interacting with the subsystem. It also promotes loose coupling by reducing dependencies on the subsystem's internal components. Look for these key clues to identify the facade pattern: a simplified interface to a complex system, abstraction of underlying complexities, and reduced coupling between the client and the subsystem. Facade pattern examples: home theater and database interactions. Consider a home theater system with multiple components: DVD player, amplifier, projector, screen, and so on. Each of these components has its own set of controls and settings. Controlling each component individually can be, well, quite cumbersome. Imagine having to turn on the DVD player, set the amplifier to the correct input, lower the projector screen, and adjust the projector settings every time you want to watch a movie. This is where the facade pattern comes in. It simplifies the process by providing a unified interface. A home theater control system acts as a facade. Instead of dealing with each component separately, you can use a single control system. It provides a simple interface like Watch Movie that handles the complexities of turning on the right components, switching inputs, and starting the movie. With just one command, the control system takes care of everything. Another common example is a database facade. Databases can be complex with numerous operations and commands. It provides a simplified interface for executing queries, inserting data, and managing transactions. Instead of writing complex SQL commands, you can use a more straightforward interface. This hides the complexities of the underlying database API. The facade pattern is all about making complex systems easier to use by providing a simpler interface. Whether it's a home theater system or a database, the facade pattern helps streamline operations and improve user experience. By using the facade pattern, you can focus on what you want to achieve without getting bogged down by the intricate details of each component. This makes it an invaluable tool in both home entertainment and software development. So next time you enjoy a seamless movie night or effortlessly manage your database, remember the power of the facade pattern working behind the scenes, simplifying complexity, one interface at a time. Decorator Pattern, adding responsibilities gracefully. The Decorator Pattern allows you to add new responsibilities to an object dynamically. It wraps an existing object and provides additional behavior. This pattern adheres to the open-closed principle. You can extend an object's functionality without modifying its original class. Key clues for recognizing the Decorator Pattern include dynamic addition of responsibilities to an object, wrapping an existing object to extend its behavior, and adherence to the open-closed principle. Imagine a coffee shop application. You walk in, and the aroma of freshly brewed coffee fills the air. The app allows you to order your favorite coffee right from your phone. You start with a basic coffee object, just like a plain cup of coffee sitting on the counter. Customers can customize their coffee with various add-ons, milk, flavored syrups, or even a shot of espresso. They can add sugar, whipped cream, or any other ingredient to make it perfect for their taste. In software development, the Decorator Pattern is a perfect fit for this scenario. It allows you to add new functionality to an object dynamically. Each add-on, like milk or sugar, is implemented as a decorator. This means you can layer multiple decorators to create a complex, customized coffee. The decorator wraps the coffee object and adds its specific behavior, like adding milk, without altering the original object. This allows for flexible and dynamic coffee customization, giving customers the freedom to create their perfect cup. Another example of the Decorator Pattern is in file handling. Imagine you have a basic file reader object. You can use decorators to add functionalities like encryption, ensuring that your data is secure. Or you can add compression to save space, and logging to keep track of file access. Each of these functionalities can be added without modifying the original file reader object. This makes the Decorator Pattern incredibly powerful and versatile, allowing developers to build complex systems with simple, reusable components. Whether you're customizing a cup of coffee or handling files in a software application, the Decorator Pattern provides a flexible and elegant solution. The Flyweight Pattern focuses on efficiency. It shares objects to support large numbers of fine-grained objects efficiently. It achieves this by separating intrinsic or shared state from extrinsic or unique state. Intrinsic state is stored in the flyweight object, while extrinsic state is passed in when needed. Key clues to identify the Flyweight Pattern include large numbers of fine-grained objects, shared intrinsic state among objects, and the separation of intrinsic and extrinsic state. Think of a text editor handling thousands of characters. Creating a separate object for each character would be highly inefficient. The Flyweight Pattern offers a solution. Each character can be a flyweight object. The character code, like the ASCII value, is the intrinsic state. Formatting information such as font, size, and color is the extrinsic state, passed in during rendering. Similarly, in graphic editors, trees or other complex objects can be implemented as flyweights. This reduces memory consumption and improves performance. Recognizing design patterns is crucial for writing clean, maintainable, and efficient code. We've explored 4 important patterns: Observer, Facade, Decorator, and Flyweight. Each pattern addresses specific software design challenges. By understanding their unique characteristics and recognizing their key clues, you can make informed decisions about their application. Mastering these patterns will undoubtedly enhance your software development skills. You will be able to craft elegant and robust solutions to complex problems.